All right, now we look into that unequal expected frequency. Okay, so we just do the comparison of the observed and expected frequency for the, especially for the unequal expected frequencies. Okay, all right, same things. All right, so we know the chi-square goodness of fit test to compare and observe frequency distribution to frequency distribution of unequal expected frequency is exactly the same as the procedures for the test which is equal frequency. So this means that the procedures exactly the same as for the equal frequencies. Okay, for the equal frequencies that what we have done just now. Okay, all right. So same things, we first need to declare the hypothesis test, which is null hypothesis. We say that there is no difference between observed and expected frequency. And then the hypothesis alternative, we say that there is a difference between the observed and the expected frequencies. All right, that's as it is. There is no any changes on that hypothesis. All right, next. All right, take a look at this example. All right, the American Hospital Administration Association report the following information concerning the number of times senior citizens are admitted to the hospital during a 1 year period. Okay, all right, 40%. Okay, 40% are not admitted. Okay, they said 40% are not admitted. 30% are admitted once, and 20% are admitted twice, and the remaining 10% are admitted 3 or more times. All right. Okay, so out of the 100, so this they already split into that category. All right. A survey of the 150 residents of Bauto Estates, a community devoted to active senior located in the Central Florida, revealed that 55 residents were not admitted during the last year, and 50 were admitted hospitals once, and 32 were admitted twice, and the rest of those are survey were admitted 3 or more times. Okay, now the question they asked whether can we conclude the survey at the Bauto Estate is consistent with the information suggested by that the American Hospital Administration Association. All right, so this is what the main objective, main questions. Can we conclude survey Bauto Estate is consistent with that information suggested by AHA? All right, so now we're going to use that 0.05 significant level, all right, or 95% of significant level or level of confidence in order to reject or accept that the statements, right? Okay, let's follow the procedures. First, we need to set that the null hypothesis and alternative hypothesis. So we can claim that there is no difference between expected and observed frequency. All right, there is no difference between expected and observed frequency distribution of the number of times per year senior adult are admitted to the hospital. All right, that's our first statement. A second statement, alternative statements, we say there is a difference between expected and observed frequency of the number of the times per year senior adult are admitted to the hospital. So this is what we're going to check between these two. All right. So we say no difference and say there is a difference. Right. So now we focus on this. Okay, we're going to prove this or reject this based on our calculation. So we choose that step 2. We choose that the level of confidence of 0.05. Okay, and step 3. We're going to calculate the test statistic. Okay, of course, we just choose the chi-square. All right, and then we choose that the critical value. All right, for this case, how many category we have? 1 admitted, 1, 2, 3, 4. Okay, there is a 4 category. Okay, 40% are not admitted, 30% are admitted, 20% are admitted twice, and remaining 10% are admitted 3 or more times. Okay, so it's a 4 category. 1, 2, 3, 4. Okay, 4 category. All right. So 4 minus 1 is a 3. Degree of freedom is 3. Okay, we said that the step 4 formulate the decision rules. So we're going to check the critical value at the level, confidence level at 0.05, and we obtain, look at the table. Okay, use the chi table. Okay, so chi table show that the critical value is 7.15. Okay, again, we got here. Next, we're going to check that the chi test. Okay, use the formula. All right. Okay. So as we know, there is an unusual small expected frequency in a cell. So chi square is applied. Okay. So the result in the erroneous conclusions, right? Okay. This can be happen because the expected frequency appear in the denominator, and dividing a very small number makes questions quite large. Yes, of course. Okay. So if it is that the denominator is small numbers, and this is any figures we just divided by small numbers, then the this will be larger. Okay, the value will be larger. Okay, so now usually in this case, two generally accepted policy regarding that small cell frequency. One is that is only 2 cells. The expected frequency in each cell should be at least 5, or for the case more than 2 cells, chi square should not be used if more than 20% of that expected frequency cell have expected frequency less than 5. Okay. All right. So based on this, it would not be appropriate to use that the goodness of fit test on the following data. Okay. 3 of the 7 cells, or 43 and above, okay, 43% have expected frequency of the less than 5. Okay. So this is the main issues when we come to that this chi square analysis. Okay. All right. So as you can see that the limitation of the chi square goodness of fit test. Okay, you can see that the example. All right. So we have the observed frequency, these expected frequencies. Okay. We have formants 30 observed, and expected frequency is 32. Okay, so when you come to this point, assistant vice president is 5, but expected, okay, the observed is 5 and expected is 2. Again, there's 5, 4, and 4, 1. All right. So now you see that this issue can be resolved by combining category if it is logical to do so. Okay. So usually it's very small numbers. All right. All right, compare the others. All right, so usually it's appropriate to just to combine all together. Okay, so we combine come under one category, right? So under president's category. Okay, this is assistant vice president, president, and senior vice president. So we can combine. The alternative we can combine. We satisfy that 20% policy. Okay, so which means we can make it in this way. Okay, so 5 plus 5 is 10, plus 4 is 14. So we just add them all together, right? So we can do that when you just come to these forms, then we have to carry out this type of steps. So now we're going to, we have a 4 category of this, all right? So we're going to analyze this based on that informations we obtain, we put in the table. Okay. So as we know, there is a 40%, all right, not admitting in hospitals, and 30% is at least once they admitted, all right, and 20% about 2 times, and 3 or more times admissions is about 10%, all right. The total is 100%. All right, and as we know, the number of Bartow residents, the given the information is 55, 50, 32, and 13. All right, this is based on the total number of the calculated. All right, the expected number of Bartow residents, right? We get 60, 45, 30, and 15 based on the 4 category. All right. So we all know that the critical value, which is 7.815. Okay. So we just set up that the hypothesis null and hypothesis alternative, and we know the level of significance, which is 0.05. We said that. Next, we're going to select the test statistic. We know the cheese test, chi-square test, all right? And then the addition rules based on the degree of freedom. We have a 3, so that is the critical value 7.8. Okay, 7.815. So we already make the addition rules, whether we're going to reject, okay, or accept based on the computed the chi-square value. All right, now, so based on the table, okay, the chi table, so we obtain that the critical value. If it is greater than 7.815, we're going to reject the hypothesis null. If it's less than the 7.815, then we're going to not to reject that hypothesis null. All right, that's the idea. All right, so once we're done, we need to develop the table of based on the information we have. We just take the observed frequency and expected frequency. So we get the numbers. Okay, we need to total up everything, and we get a 1.723, which is chi value. Chi-square value, we obtain 1.3723. All right, now this value, you need to compare with the critical value. So obviously it's less, okay? So it's less than 7.815. So which means the decision, we can say that you fail to reject that hypothesis null at the significant level of 0.05. Okay, so step 6, we can say that the difference between the observed and that the expected frequency is due to chance, and we can say that there is appear to be no difference in the distribution of that hospital admission, or we can say that the hospital admittance for that Bartow estate community. Okay, so that is that how we need to conduct the goodness of fit test for that this type of cases. Okay. All right, so limitation, I just explained to you, all right, how we're going to do the limitation. We have a 2 category, right? I just explained these things, all right. And then we also have the contingency table analysis, right? So contingency table analysis, somehow we have the table and we come up with that calculation as how we did before. All right, take a look at this example. A contingency table used to present observed frequencies for 2 traits of characteristic. Okay, each observation is classified according to the 2 nominals like scale area or scale criteria. We are interested to know if there is a relationship between the 2 variables. Okay, so the 2 variable means there is a plate and did not plate. Okay, so this is the things we're going to analyze. All right, so we can analyze that the contingency table to determine if the relationship exists between the 2 variables. For example, we may have interested in a relationship between income level and the person's decision to play the lottery. So this is income is low income, middle income, high income. And then we're going to compare the result for those who played and who do not play. So we can find any of this combination, any of the two relationship. So with the middle income for the case, this is the two-way table. So two-way tables, we have the two informations in order to do the comparison and see the relationship. All right. Okay, so this is the type, all right, table for the quantitative table for the analysis. All right. Now, take a look at this example. Okay, the Rainbow Chemical Incorporation's employ hourly and salary employees, right? And which means they have a permanent job. They got a payment as monthly. The vice president of the human resources surveyed and random sample of 380 employees about satisfaction level with the current healthcare benefit program. At 0.05 significant level, it is reasonable to conclude that the pay type and level of satisfactions with that healthcare benefit are related. So you need to check, is it reasonable to conduct that the pay type and level of satisfaction with that healthcare benefit are related. So this is what your question and your objective. Okay, this is your objective. All right, so you need to answer this question. So you based on the statistical analysis. All right, as we know, we have two-way tables. One is your salary is satisfied, neutral, and dissatisfied. And we have the two types of salary. One is salary by month, another is hourly payment. Okay, so that's what we're going to calculate. All right. As usual, the first step, you need to set that the hypothesis null and hypothesis alternative. So hypothesis null, you can say that there is no relationship between the pay type and level of satisfaction with that healthcare benefit. All right, does that use hypothesis null? And the hypothesis alternative, what we're going to prove, we say that there is a relationship between the pay type and level of satisfaction with that healthcare benefit. All right. All right. Now, so we're going to prove this, whether you're going to accept and or reject. So next, the level of confidence, we choose 0.05, and we use the test chi-square test formula. All right. And now we make the decision rules. So decision rules, we need to set that the critical value. All right, now, as we know, the number of rows -1 times the number of columns -1. So you should aware on this. All right, number of row, you need to subtract 1. Okay, and then number of column, you need to subtract 1. Okay, so which mean, so how many rows you have? You have 2 rows and 3 columns. Okay, so 2 rows, 2 minus 1 and 3 minus 1. So you get a 2. Okay, so degree of freedom is a 2 now. So at the significant level, 0.05. So the degree of freedom is 2. So you just see the corresponding value or the intersection value, which is 5.991. So which means your critical value, okay, your critical value, this is n minus 1 is k minus 1. So you get a 5.991. Okay, all right. So that's your critical value. So now we're going to calculate that your chi-square value. Okay, chi-square value. Okay. Now, so the expected frequency, you can say that the row total times the column total divided by grand total. So that is a formula you need to know. So they give you some example here to calculate that. Okay, so you're gonna do that according to that the way how we just used the formula. So you just write down all the information. Okay, as we know. All right. So based on satisfaction and neutral and dissatisfaction. All right, for the salary and hourly. All right. So now next one that you need to take the observed value. Okay, to the expected value, right? Use the formula and you obtain the value. You need to add up all together and you get the values 2.506, and you check with that the corresponding critical value what we obtained just now is a 5.991. So this is a smaller value, so less than the critical value, then we fail to reject that hypothesis null at the significant level 0.05. So we can say that interpretation, there is no relationship between that, the type of pay and satisfaction with the healthcare benefit. So that's how we need to conclude.